Welcome to this explainer. Today, we're diving into a fundamental, honestly massive shift in how we interact with the spaces we live in. We usually think of our home networks as just simple gateways, right? Just a router sitting in the corner, blinking away, connecting our phones and laptops to the internet. But what the data and recent industry roadmaps are actually showing us is that our homes are evolving into autonomous, private supercomputers. Let's dive in and see exactly how our Wi-Fi and computing hardware are converging to make this a reality. It's a bit of a mind-bending shift to think about. Seriously, what happens when the Wi-Fi in your home stops just connecting you to the internet and starts actually watching you? And okay, I don't mean that in a creepy, dystopian way, but in a physical world awareness kind of way. Your wireless network is literally transforming from a basic digital data pipe into a sensory organ for your home. It's a fascinating technological leap. And to really grasp it, we need to first look at the foundation of this shift. So let's start with Section 1, Beyond Speed and Cloud. There's this super common misconception that future tech is only about achieving faster cloud processing. But consider the contrast in priorities between Wi-Fi generations. Wi-Fi 7 is an incredible standard. It's built on a technology called multi-link operation, or MLO, which lets devices transmit and receive across multiple frequency bands, like 2.4, 5, and 6 gigahertz, all at the same time. In recent tests by Cisco, an MLO setup achieved average throughputs of 747 megabits per second, and it theoretically peaks up to 5.8 gigabits per second. Just blistering raw speed. But Wi-Fi 8? It's taking a totally counterintuitive pivot. Instead of just chasing a higher top speed, Wi-Fi 8 is officially focused on something called Ultra High Reliability, or UHR. So you might be wondering, why this sudden shift away from pure speed? Well, the answer actually lies in the cloud, and specifically how insanely expensive it's getting to run AI up there. Cloud AI, especially for centralized processing and training, is becoming really unpredictable in cost. Amazon, for example, recently hiked the prices by 15% for certain machine learning GPUs. Because of this, the market intelligence firm IDC predicts that by 2027, a staggering 80% of CIOs will turn to local edge services instead of the cloud for AI inference. Processing is moving out of those distant server farms and right into our homes and offices. And to support that massive shift, our local networks need to be absolutely bulletproof. Which brings us to Section 2, Wi-Fi 8 and Ultra High Reliability, also known as the 802.11bn standard. Let's dig into the specific mechanics of this upcoming standard. Slated for finalization around 2028, Wi-Fi 8 is being engineered to completely eliminate those incredibly frustrating dropped packets. The targets here aren't about maximum peak speeds in a perfect laboratory. They are about guaranteeing performance in terrible conditions. We're looking at a 25% improvement in throughput during challenging signal conditions, 25% lower latency at the extreme edges of performance, and 25% fewer dropped packets. Plus, it introduces something called single mobility domains. This means as you walk around your house, multiple access points coordinate perfectly to hand off your device without a single stutter. That seamlessness is absolutely crucial for real-time edge computing. And this quote brilliantly illustrates exactly why Wi-Fi 8 is built this way. Rolf de Vecht from Qualcomm points out that, whether wearable, embedded in smart environments, or autonomous, AI-driven systems demand reliable, low-latency connectivity to access edge or cloud-based AI for real-time inference. AI is the true driving force here, right? An autonomous AI agent managing your home simply cannot afford a dropped packet. It needs continuous, flawless connectivity to do its job. All right, moving to Section 3, Wi-Fi Sensing and IEEE 802.11bf. Now we arrive at the real sensory hook of our explainer. This is where we bridge the gap between digital networks and the physical world. Wi-Fi sensing, officially known as the IEEE 802.11bf standard, is a technology that uses the physical layer of your Wi-Fi network to act essentially like a radar. By analyzing what's called channel state information, or CSI, your router can measure how standard Wi-Fi radio signals bounce off physical objects. Basically, it reads the radio waves that are already bouncing around your living room right now to detect physical events, without needing a single traditional camera. The applications of this are straight out of science fiction. Because these Wi-Fi waves are so incredibly sensitive, changes in the environment can actually be categorized. We are talking about intruder detection or fall-down detection for the elderly. It can recognize hand gestures. It can even perform biometric monitoring, literally detecting the tiny chest movements of your breathing or the beating of your heart. Just think about that. Your standard home router becomes a powerful spatial localization and biomonitoring system. It's wild. So here's the crucial point. If your Wi-Fi is constantly generating real-time data about your breathing, your heart rate, and exactly where you are in your house, sending all that incredibly sensitive data to a random cloud server introduces unacceptable latency and massive privacy risks. You absolutely need a local solution to process this data instantly. Which naturally leads us to Section 4, the Home AI Supercomputer, where edge computing meets the home. This brings us to the brain of the entire operation. You might have heard wild rumors about Nvidia turning houses into data centers, but the underlying truth is deeply fascinating. Nvidia has been pushing systems like the DGX Spark, which is basically a desktop-sized AI supercomputer. Even more interesting, reports indicate Nvidia is partnering with a startup called Span to test what are known as XFRA nodes. These are mini AI data center units designed to attach directly to your home's electrical panel, tapping into unused residential electricity to power local AI inference hubs. And to build this, you don't just shove one giant server in the basement. You create a distributed, local, large language model system using the computing power scattered all around your house. By using software frameworks like Ray and VLLM, you can establish a head node on a primary machine, connect worker nodes across your network, and launch distributed inference. This uses a really clever technique called tensor parallelism, which splits the AI workloads across multiple local GPUs in your home to create one single, functional, continuous home supercomputer. And the efficiency of doing this is just staggering. According to research on hybrid edge cloud processing, utilizing local edge context for agentic AI workloads can reduce energy demands by up to 75% and cut costs by over 80% compared to pure cloud processing. It totally bypasses the massive computational complexity and energy demands of centralized data centers by doing the heavy lifting right exactly where the data is actually generated. Now let's wrap this all together in Section 5, Achieving Zero Trace Privacy. We've talked about the speed, the sensing, and the amazing computing power. But let's focus on the real practical anchor of this convergence: privacy. Keeping biometric Wi-Fi sensing data, personal financial details, and private conversations securely inside your home is the ultimate solution to modern privacy concerns. As this quote perfectly notes, using secure local frameworks creates a privacy sandbox inside your own four walls, meaning your data never ever has to be analyzed by a distant corporate server. When you combine Wi-Fi 8's flawless reliability, Wi-Fi sensing's physical awareness, and local edge AI processing, you get three massive benefits. First, 24/7 autonomy. Your smart home keeps functioning, protecting, and managing itself even if the external internet totally goes down. Second, zero trace privacy for your most sensitive personal data. And third, your home becomes a secure digital twin hub, acting as a local brain for your phone, your smart glasses, and your appliances, with everything processing securely in one single place. We are moving away from an era where technology just simply connects us to the outside world and stepping into an era where our homes are deeply, privately aware of us and capable of profound local intelligence. So I want to leave you with this final thought. When your home is fully equipped as a highly reliable, physically aware, and entirely private supercomputer, what will you teach it to do? Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.